Hey Heather and Harper, I hope you guys are having a great weekend at your volleyball. Hope you guys win another tournament. And I know regardless of how good your weekend is, it's going to get a whole lot better now because we're going to do some math, okay? So we are going to do 4.4 applications of systems of equations. Basically, this is our word problem section. So we're going to make equations, we're going to find the intersection points. Okay. The first example we're going to do, this is your basic. This is the gimme question if you get it on your exam because I'm giving you the equations. In this scenario, there is a stunt person jumping from a tower, and they are in free fall before she opens her parachute. Now, her height is all of my h's, and t is my time. There's one equation, and this is before the parachute was opened. This is modeled by the equation h is equal to negative 4.9 t squared plus t plus 350. But when she opened her parachute, there was a change. At this point, the equation can be modeled by h is equal to negative 4t plus 141. If you notice, that is a quadratic linear system. So the easiest way to do this, if I'm trying to find the time when she opened her parachute and the height when she opened her parachute, is to graph it. When you see a decimal, lean towards the graphing method of solving. So I'm going to pull up my graphing calculator here. And sorry, I have to do the debug one here, so I'm going to try and be as efficient as I can with my time. In my y1, I'm going to put my first equation, so my negative 4.9 t squared plus t plus 350, second equation in the second y1. So when I graph it, if you notice, this is not a good picture. So I'm going to need to adjust my window. I know I need to see a whole lot more on the top. So I'm going to change this Y max to let's try 500 and see if that works. Oh, look, beautiful window. On purpose? Oh, yeah. Okay, so the first thing I'm going to do is do a rough sketch on the side here. So I have my parabola, line going through it. Well, that's not even the best line. Let's maybe try that again. There we go. I need to find this intersection point right here. Now, easiest way to do that is do our second trace intersect. Scroll on over to that area, and I will press enter, enter, enter. That's telling me the point is at 7.1 and 112.8. So I'm going to label it as 7.1 and 112.8. Now I have to figure out what that means. Okay, so y is my height, x is my time. So the intersection point has a t value of 7.1. So how many seconds after the jump did she open her parachute? 7.1 seconds. At what height did she open that parachute? Well, to the nearest tenth, it was 112.8 meters. So that's our first equation, and hopefully that one isn't too bad for you. Now, this is kind of a practice question, and it's going to be very similar to it as well. But in this one, I'm going to throw a tennis ball off the roof of a building, and I'm also going to be throwing a basketball upwards from the ground. So I have two different equations. If you recognize right away, they have decimals, so graph this one as well. My goal is to determine the height and the time at which they have that intersection point. So essentially they meet. Okay? So once again, grab your graphing calculator. Put in your y1 and your y2. So continuing on here, if I pull up my graphing calculator, I'm going to put my first equation into my y1. So this will equal negative 4.9 x squared, subtract 10x plus 50. For all of these, go back to your standard window, okay, and start from scratch every time. Now, this isn't the best window, but it looks better than the last one I had to start with. So I'm going to change this y max to something like 70. Okay, here this is a really good window. I can sketch it if I want, and I also need to find the intersection point. Now that intersection point is this point right here, okay? So that's where those two balls are meeting, so I'm going to use the second trace intersect function to figure out that exact position. So enter, 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 and it's going to be at 2 and 10.4. So now I'm going to sketch it, and I'm going to answer my questions. And that is at 2 and 10.4. Okay? So what do those two things mean? Well, once again, this is my height and this is my time. So at what time will they be the exact same? Well, that time will be at 2 seconds. And what is the height? It is 10.4 meters. So now I've sketched it. I've told you what the height is. Now where do these A, B, and C values come from? Well, hopefully you know C. C is the tossed from height. B is the original force applied to the object. And the A term, this is more like gravity. This is how gravity is acting upon the ball. Okay, so here I've solved this one. Now D right here, this is just kind of like extra information, just kind of a side note in case you were wondering. Okay, so those are two kind of like projectile path launched questions. Now we're going to move into a new style, which is the two number style. Okay, so there are two numbers related in this way. 2 times the first number subtract 5 is equal to the second number. That sounds way more confusing. Quick. If you slow it down, it's not so bad. So I'm going to try and create a system from that right away. Okay, so 2 times the first number. Let's go to F. First number we'll call F, and the second let's call S. So 2F subtract 5 is equal to the second number. That's my first equation. My second equation comes from my second sentence. The sum of the second number and the square of the first is equal to 115. I have two equations. Now, I could graph it, but I don't think that graphing is the best way here. So what I'm going to do is I'm going to do a substitution. Here, S is isolated, so I'm going to put it in for that S right there. So now we'll have 2F subtract 5 plus F squared equals 115. I'm going to push everything to one side of the equation and rearrange in descending order. So I have F squared plus 2F subtract 120 equals 0. Do the diamond. Negative 120 and 2 gives me positive 12 and negative 10. So I make my two sets of brackets and I have F plus 12 and F subtract 10. So now I have two possible F values. F is equal to 10 and F is equal to negative 12. Once again, this isn't too bad to actually punch into this original equation. So I'm going to go 2 times 10 subtract 5. Well, 20 subtract 5 is 15. So there's one solution at 10 and 15, where this is the first number and this is the second number. In the other example, I have 2 times negative 12 subtract 5. This is negative 24 subtract 5 is equal to negative 29. So I have another solution at negative 12 and negative 29, where this is the first and this is the second. So there are two possible solutions for this question. The following example is basically a practice for you, but it's kind of a gentle lead-in. Here I have two numbers that are related, and I have 3 possible options for my answer. The easiest way to kind of do this is to actually make your equations and then match them up. So the sum of the first number and the square of the second is 18. The difference, that's subtracting, between the square of the second and twice the first is 12. So I have my two equations. Now if you notice, I have F's and F and S's, and they have X and Y's. So I'm going to just turn every X, or every F into X, and every S into Y. So now I have X plus Y squared. Well, that's right here. It equals 18. None of these other ones are going to work for my first equation, but let's check to see if the second equation works too. Is Y squared subtract 2X equals 12 my equation? Why, yes it is. So there's the two equations that I could have used. The next one here is another practice. Try this one on your own. Pause me and then see if we get the same answer, okay? So the square of the first, subtract the second is equal to 5. And I also have the first number is equal to the second number, subtract 7. Once again, use substitution. It's going to be the easiest one here. So I have s subtract 7 squared, subtract s equals 5. Okay, when I square something it means multiply it by itself. So here I have s squared subtract 14s plus 49, subtract s, and let's move over that 5 too. Subtract 5 equals 0. Combine my like terms. I'm going to try and diamond. When I diamond, I have 44, negative 15. My two numbers are negative 11, negative 4. So I have s subtract 11 and s subtract 4 equals 0. So I have two possibilities for my smaller number, either 4 or 11. Now I can plug those into one of my original equations, and if I use, well, that f is equal to s minus 7, that doesn't look so bad. So I'm going to have 4 subtract 7 equals negative 3. So I have one possible solution at 4 and negative 3. The other one is going to be 11 subtract 7, which is 4. So I have another solution at 11 and 4. Okay, so those are the two possible sets of numbers that I could use in this one. Now, this is your challenger. This is the big one. This is what you want to be able to get if you want to get 100% on your next exam, because it's not going to be easy. I know there's only 4 sections, but don't take it lightly. This is also going back to last unit. So I have the number of students attending a leadership conference depends on the price charged. It is determined that 20 students will attend the conference if each is charged $75. For each $10 increase, 1 fewer will attend. Now there's this other scenario. It says the cost of running the conference is a rental fee of $1,000 plus $75 per student. Create a system of equations. So from the first one, if you remember, revenue equals cost times the units. So what is my cost? Well, 75 plus my $10 increase times the units. Well, 20 subtract I. This is my revenue. This is my one equation. The other one will come from my cost. What is the cost? Well, it's a one-time fee of $1,000 plus $75 per student. Okay, I have two equations. I've developed them. This is going to be a good graphing scenario, okay? Okay, girls, so this, like I said, is a great graphing situation. So in my y1, I'm going to put my 75 plus 10x and 20 subtract x. So remember, x is my number of increases. My cost will go in the second equation, and I'm going to graph it. This is a really bad window. So I'm going to adjust my window. I'm going to make my x max, let's say 20. Okay, that helps. Now my y still needs to go way up. So I'm going to take it to about 2,000. Okay, this is a really good graph now. I want to know the intersection point right there because it's in quadrant number 1. So when I go enter, 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 it's going to give me an answer of 10 and 1750. Okay, so I'm just going to do a rough sketch and write that answer down. So this was at 10 and 1750. Now this is the point in which the cost and the revenue are the exact same. So what does this mean? That intersection point is the break-even point. So at that point, x is equal to 10 and y is equal to 1750. And if you recall, 1750 is another word for revenue or cost. And if revenue and the cost are the same, then it is my break-even point. Like I said, this is your challenger question. Now, ladies, over the weekend, I want you to review those different topics. If you have any questions about this or any of the other lessons, you can definitely throw it in the comment section or email me and I'll get back to you. Your unit assignment is going to be due on Monday Pop in if you need help. Have a great weekend, and I hope you rocked your tournament.